Hi, this is Lori, and this is my homework or walkthrough for day 6 of the Cogsworth City Kit by Adventure.io. This is the wiring diagram for the adventure on day 6. We have 2 LEDs, 2 buttons, and 2 photoresistors on it now. When I went through this lesson, it wasn't quite the same. I think I'm not even sure this wiring diagram was exactly like this. I can't remember for sure. But I know one thing it did suggest was using a temperature sensor here instead of 2 photoresistors. You have 2 in the kit, and there is no temperature sensor in the kit. And I mentioned at the very beginning of my walkthrough that I supplemented the kit with a few things, and one of them was a temperature sensor, a DHT11. We'll talk about that in a minute. There's also 2 buttons on here, and I guess the idea is you can turn on the light either with the button or with the photoresistors, depending on the light level. And yeah, I thought that's okay, but it feels redundant to be able to turn it on with 2 different approaches. I guess it's just a different idea. So I didn't put the buttons in my circuit at all. I used the sensors only to turn on or off the LEDs. So I have a photoresistor in here, and when you see my setup, you'll also see that there's a temperature sensor, the DHT11, in here. And these 2 control whether the lights come on or off. These are the various temperature sensors that I happen to have handy. The one I'm going to be using is this DHT11, and it's mounted onto this breakout board. Sometimes you'll see them not mounted onto a breakout board, and if that's the case, then there is a resistor that needs to be wired in here, and you probably just Google that up and you'll see how to hook that up. Otherwise, you just plug this in, and you've got power, ground, and then your signal pin. We'll see when I show the actual setup. Kind of the sister to that one is the DHT22. I think it's a little more expensive. I got both of these in kits, so I didn't buy them individually. I think this one's supposed to be a little more accurate, and I haven't really noticed a big difference between the 2 of them. I've actually run them side by side in the past. I haven't really seen a big difference, but you know, either of these will work with the code that I'm going to share. And then if you really want to get into more accurate measurements, the BME 680 and the BME 280, a little bit cheaper version, you can purchase those, but you're going to spend a lot more money. They can do a lot more, and the 680 is nice. You can kind of use that to do indoor air quality. But if you don't need to do something like that, these cheap ones that you can usually get in kits are just fine for messing around with temperature and humidity. All right, here we are with our code for this adventure. And I'll just start off by showing the setup I have. So I have the 2 LEDs just like shown in the lesson code, and then I have 1 of the photoresistors here. And instead of the second photoresistor, I've set up my DHT11, and you can see it's going to pull it out briefly here. And I'm going to bring up my monitor so I can make sure things are focused and so forth. So this is the one that I happen to have. And on the back, you can kind of see how it's connected. So there's a negative, positive, and a signal. It's a little different than the one I showed in the slide, the one I happened to pick up. So now you can see it's going to plug into ground, then power, and then to the signal. So I'll just slide it in like that. Yeah. So hopefully that's still, yeah, that looks good. So that's how you would set one up, and you just connect it into one of these pins over here. So yeah, so no buttons. So depending on what the value of this is, it'll turn on one of the lights, and depending on what the value of this is, it'll turn on the other one. All right, so let's just take a look at the code. Let me get my monitor out of the way. There we go. Yeah, so here's the code I put together, and I write some stuff in the code. As always, this is going to be up on my GitHub site. Um, and I mentioned I noticed that this change between when I did the lesson and then went back and looked at the instructions again, and they had changed. All right, so it's the lesson is now doable with what just comes in the kit. So I think that is a good thing. But if you want to use the DHT11, you'll need to load a library to use it. So when you start using more advanced sensors, I guess sometimes they need libraries. The DHT11, DHT22 are such sensors that would need a library. And the one I'm going to use is one from Adafruit. So you'll need to load that, and I think I talk a little bit about it here. Yeah, use the library manager. So here we go, up here in the library manager. You could type in something like Adafruit sensor, and hopefully let's see, what else was it called? Unified Sensor Library. Let's see if we can find that. Adafruit Unified Sensor. And there it is. And now you can see I have mine installed, but if you didn't, you click the install button and it'll ask you if you want all the dependencies installed, and you just say yes to that. Okay. So yeah, and if you click on more info, it'll take you to a website that'll show you more info about the library and so forth. That's all you need to do that. So that's the library manager if you haven't ever used that. All right, and then you just have to bring that in. So this is the library. The include, the hashtag include will bring that library in. And then I'm using the define statements here. We probably could have just made them variables too, but this is the way they showed in their example code, so I left it the same. So we just tell it which DHT type we have. So I'm using the 11, but you saw that I had the 22, so you would change it to 22 if you have that 22 type. And then what pin are you connecting it to? So I'm connecting it to 8, and then here's where you kind of set up the object for that sensor. Then here we have the photo pin for our photo resistor, the LED lights, my red one and my blue one. Then I'm going to do something similar to what I've done before with those lights. I'm going to look at what the initial light value in the room is. I'll set a threshold. We'll get the current light value and decide how to turn on the light depending on differences from the initial light level. And in void setup, we just need to start the sensor, and we need to set up our pin modes for our two lights. And I think I say on here that the temperature is going to be changed by the red and the light's going to be changed by the blue. So we'll see how that works out. We'll start the serial monitor because we'll want to print to that and see the status of things. And we'll make our initial reading of the light. Then in the loop, we'll read the temperature. Got some construction going on outside, so hopefully it's not too loud. So we'll read the temperature, and this is how we would do that. And the library kind of tells us how to use this library here. So that's this code from the library. And we're reading it in Celsius. And then we'll read the photoresistor. And then we'll print the temperature and the light level to the serial monitor. And then if the temperature is above 25 degrees Celsius, we're going to turn on the temperature pin, and otherwise we're going to turn it off. And if we have a significant enough change in the light level, we'll turn on the light pin or we'll turn it off. And these cheap sensors should not be read too often. So I think it says about 1 to 2 seconds, especially for the DHT11. So I just made it 2 seconds delay as we go through the loop, just so we don't read that too frequently. All right, so let's see it go. So we'll make sure it's loaded here. I'm just going to double check and make sure it's loaded. Yeah, I think they're putting in somebody's driveway today. All right, and we'll put the serial monitor, start it, and hopefully we'll start to see. Yeah, here we go. Here's our temperature and here's our light level. So let's just try the photosensor, the photoresistor, I should say. And you can see. Now it's not going to turn off right away even though I cover it because it's waiting 2 seconds. So you can actually see that 2 seconds. It takes a little while for it to go off once I've set it down. So yeah, that's pretty good. All right, and try to get this to turn on. We'll have to warm it up. So I'm actually going to pick it up and blow on it with my breath a little bit. So let's see what happens. You can see the temperature going up. I'll put it back into the view. Hopefully you can see it. Yeah, now it's on. And it's going to stay on probably for a little while because I got it pretty warm, it looks like. But it's starting to drop back down. And as soon as it drops back down underneath 25, the light will turn off. So yeah, that's how simple it is to use one of those DHT11s. Just have to load that library and learn from their example code how to interact with the sensor itself. And it's just good experience because any of these sensors that need libraries, well, it's kind of nice. Oh, you can see it finally dropped back down, and the light came off. Well, that's my walkthrough. Slight difference in how I decided to do this adventure. And as always, I want to thank you for watching.